Let's look at some problems where we're calculating Gibbs free energy. For the values of delta H and delta S, predict if the reaction will be spontaneous at 25 degrees Celsius. If the reaction is non-spontaneous, at what temperature would it become spontaneous? So the first thing we need to note is that we are looking for a delta G value less than 0 for a reaction to be spontaneous. And we also need to know that we're going to be using our temperature in Kelvin, so we want to say 25 plus 273 will be 298 Kelvin. So that's the temperature we'll use in our calculations. Now we want to look at our first problem here. We're given a delta H value of 15 kilojoules per mole and delta S of 29.5 joules per mole Kelvin. We're going to use the equation delta G equals delta H minus T delta S to solve for our Gibbs free energy. We do need to be careful because our delta H is in terms of kilojoules and our delta S is in terms of joules. So we want to say delta G equals 15.0 kilojoules per mole. And I'm going to go ahead and put the conversion in to take this one to joules. So 1,000 joules in 1 kilojoule minus my 298 Kelvin for my temperature times my delta S value, which is 29.5 joules per mole Kelvin. And when I solve this, what I see is I get a delta G value equal to 6209 joules per Kelvin. Now it doesn't really matter whether I convert to joules or kilojoules as long as we get both values with respect to the same units. My delta G value here is greater than 0, so that lets me know my reaction is non-spontaneous at this particular temperature. But I want to see if there's a temperature at which it will become spontaneous. And so what I want to do is I want to find that temperature. So I'm going to set up the same equation, but solve it for the temperature this time instead of the delta G value. So what I want to do is for my delta G value, this time I'm going to put in a value of 0 because I know that I have a positive delta G value. I want to get to a negative delta G value. In order to get there, I'm going to have to go through 0. And that's also where I'll change from being a non-spontaneous process to a spontaneous process. So I say 0 equals, and I convert this. I have my 15,000 joules per mole, because I've already converted my delta H to joules, minus T, I don't know that this time, times my 29.5 joules per mole Kelvin. And when I can rearrange that, and I end up with 15,000 joules per mole equals T times 29.5 joules per mole Kelvin. And when I solve that, I end up with a temperature equal to 508 Kelvin. And if I subtract 273 from that, I get 235 degrees Celsius. So at temperatures greater than 235 degrees Celsius, I will have a spontaneous process. Note that at 25 degrees, we were a non-spontaneous process. As we go up to 235, we get a delta G greater than 0. If I continue on past 235, I'm going to see that my delta G value will now become negative. Now let's look at another example. We're going to start this one the same way. We're going to have delta G equals delta H minus T delta S. My delta G value is minus 250 kilojoules per mole. And just so I can show you can do it either way, I'm going to leave it in kilojoules. I'm going to convert my S value to joules. So I have minus 298 Kelvin times 17.0 joules per mole Kelvin. And I'm going to convert that joules to kilojoules. So 1,000 joules is 1 kilojoule. And when I solve for my delta G value, I end up with minus 255 kilojoules per mole. Since this value is less than 0, I am dealing with a spontaneous process. So delta G less than 0, spontaneous, delta G greater than 0, non-spontaneous.